So this is the review for our quiz. Express all answers in simplest radical form. Feel free to use your calculator. If you want to check to see that your simplified radical has the same decimal equivalent as the regular radical or the original radical. Also, what you can do is use your square root chart. So for the square root of 48, I'd break that down into the perfect square of 16 and the irrational number square root of 3. The square root of 16 is just 4, so this final answer is just 4 square root of 3. Number 2, two separate radicals. You can separate them each and then multiply through, or you can do one big radical. I'll show you both ways. Radical 18 times radical 20 is radical 360. Radical 360 can break down into perfect square radical 36, times radical 10. Square root of 36 is just 6. Radical 10 doesn't get broken down any further and you're done. The other option that you have for this one, and I'm going to bring up a new page, there's nothing wrong with breaking down these two radicals separately. Really, it comes down to being really your preference, what you like better. So radical 18, radical 20 becomes radical 9, radical 2 times radical 4, radical 5, right? So I'm sure that you can kind of see what's going on here. But this radical 18 is what's here. This radical 20 is what's here. So all then you would do now is say, okay, well, the square root of 9, 3 drops out. The square root of 4, 2 drops out. I can't do anything with rad 2 or rad 5. But now if I multiply my outside radicals is 6 and my under radicals is 10. Same answer that we got on the other page. Okay, your choice. Either way, number 2 comes out to be 6 root 10. I don't care how you do it, just get the right answer. The next one, number 3. Negative 3 rad 12 times 5 rad 45. This one, because these numbers are pretty big, I am actually going to separate everything. All right, this is just my choice. So I'm going to take negative 3 rad 12 to negative 3 rad 4 rad 3. And I'm going to take 5 rad 45 to 5 rad 9 rad 5. Remember, it's all about multiplication. Well, this is a perfect square, 2 drops out. This is a perfect square, 3 drops out. If I start dealing with numbers that are not inside a radical, negative 3 times positive 2 times positive 5 times positive 3. All of that multiplies out to be negative 90. So I've got negative 90, and then under my radicals, multiply out to be 3 and 5. 15 under the radical is simplified. There's no perfect square factors of 15. Number 4, what I notice here is that where radical 24 can be simplified, radical 36 is a perfect square. So the square root of 36 is just 6. Radical 24 can be broken down into radical 4 times radical 6. The square root of 4 is just 2. So if I bring this all down together, I'm going to get 2 radical 6 over 6. But remember, you're allowed to simplify things that are both in or both out of square roots. Well, the 2 and the 6 both out of the square root becomes 1/3 with my radical 6 in the top. The 1 on the outside of root 6 is not necessary. It's not wrong either. When I get to number 5, I realize that I need to get rid of the square root in the denominator. You can't have a square root in the denominator. You need to rationalize. Basically, what you're doing is you multiply both top and bottom by the radical that's on the bottom. Because any radical times itself just turns out to be the number underneath the radical, but no symbol. So root 27 times root 27 is root big number, no idea. But that just breaks down into 27. On the top, I've got negative 9 on the outside of a radical 3. Multiplying that by a radical 27 becomes negative 9 square root 81 over 27. Well, the square root of 81 is just a 9. So I end up with negative 81 over 27. And this thing simplifies to negative 3. Number 6. Look for like radicals. I've got negative 9 radical 2's and 1 radical 2. That's negative 8 radical 2's. Negative 1 radical 5 plus 4 more radical 5 becomes plus 3 radical 5. You are done. Seven. 2 radical 75 minus 6 radical 108. Well, radical 75 becomes 2 rad 25 rad 3. 108 becomes minus 6 rad 36 rad 3. Perfect square, 5 comes out. Perfect square, 6 comes out. I've got 10 radical 3 minus 12 radical 3, which ends up, sorry, not minus 12. Don't add them. Don't do what I just did. Don't add those guys. Minus 36 radical 3, which becomes negative 26 radical 3. 7 rad 32. This becomes 7 rad 16 rad 2. I can't touch the negative 5 rad 3. I can't touch the negative 2 rad 2. But then I've got negative 3 rad 45, which is negative 3 rad 9 rad 5. This becomes a 4. This becomes a 3. Now I'm going to write everything out. So I've got 28 rad 2's minus 5 rad 3's minus 2 rad 2's minus 9 rad 5's. The only like terms I have are in the rad 2's. That's it. It's okay. Not everything has to be a like term. 28 minus 2. So I've got 26 2's minus 5 of the 3's minus 9 of the 5's. Not everything has to simplify into one radical. In this case, there's 3 separate. Not a big deal. 9, distributive property. When I distribute, I get negative 30 outside a radical 40, and then I get a positive 42. Did I multiply wrong again? I sure did. Oh boy, let's try this again. So it's negative 30 outside a radical 80. Does that look better? And then it becomes plus 42 outside a radical 20. Well, 80 is 16 times 5. So negative 30 rad 16 rad 5 plus 42 rad 4 rad 5. I'll start from the right. 2 falls out, 4 falls out. Then I get negative 120 of the square root 5's plus 84 of the square root of 5's. And 120 negative plus 84 is negative 36 rad 5's. Last but not least, distributive property. When I FOIL this out, I get 4 rad 25. Then I get minus 14 rad 15. Then I get plus 14 rad 15. And then I get minus 49 rad 9. Well, these guys are actually opposites. So these, negative 14, 15 plus 14, 15 is just 0. What happens up here is radical 25 is just 5. Radical 9 is just 3. And then I've got 4 times 5, which just gives me 20, minus 49 times 3, which gives me 147. And 20 minus 147 is negative 127. So for tomorrow, you need to make sure that you can simplify radicals like number 1. You can multiply radicals like 2 and 3. You can divide radicals like 4 and 5. You can simplify radicals by changing them over and then combining like terms, which was 6, 7, and 8. And then 9 and 10 is all about the multiplication. Okay, good luck on the